All right, 7.3 today. This is logs as inverses. When I say logs, that means it's a logarithmic, right? This word is actually L-O-G-A-R-I-T-H-M-I-C. That's why I just say logs. So it actually, a log is an inverse of an exponential. And we've been working with exponentials for the last few days. So remember that an exponential, right, was always y equals ab to the x, right? So I'm going to write it as b to the x, assuming that a is 1. So if I'm doing an inverse of that, we switch x and y around. So I get x equals b to the y. All right, so the inverse to that is actually a log function. This can be rewritten as log base b of x equals y. So you can see we've solved for y. These are inverses of each other. Okay? This is the exponential form. And this one is the logarithmic form. All right. Okay, so the first part of your homework today, you're actually just rewriting it from this form into this form. We've got to get used to switching them back and forth. So here's example number 1. I'm just going to say write in log form. All right, so you're going to have something that looks like 36, maybe 36. 36 equals 6 squared, which we know is true, right? So this is exponential form. This is, if you look at this one, this is the x, this is our b, and this is our y. Right? Fits right along with how this is written. So to rewrite this in log form, we write the word log. Then this little b, it's a little base at the bottom, is the number 6 in this case. Then behind the b is our x value, which is 36, equals our y, which is our exponent, 2. So we're just taking it from this form and rewriting it in this form. Here's another one. I have 125 equals 5 to the 3rd. So again, this is my x. This is my b. It's like the base to the exponent. And then my 3 is my y. It's my exponent. So we have log base 5, that's the base here, of 125 equals 3. Rewriting them from this form into this form is what you have to do for numbers 12 through 19. It's just rewrite them. That's it. There's no math to do. There's no anything to do. You just rewrite it. Let's do one a little bit tougher real quick here. How about, move this up a little bit. What if I had it written this way? Let's say I have, I don't know, 1/2 to the 3rd equals 1/8. So I flipped it this time, right? Out of these 3 numbers, this one is my x value. This one, which is the base to my exponent, is my b value, and my exponent is my y. So when I rewrite it in log form, I have log. The b is my base, which here is 1/2. So it's a little tiny 1/2 at the bottom. Then my big number of 1/8 equals 3. Anybody have a question how we rewrite these? Excuse me. I know there's something a little bit different. Okay, so let's go on to example number 2 then. Example number 2. So I just asked you to take them from exponential form and to rewrite them into log form. So now this time, let's write each log into exponential. So if I have log base 2 of 16 equals 4. And I want to remind you, this is my base, that's my b, right? This right here is my x value, and this is my y value. So we're going to rewrite it. And let me put it over here as x equals b to the y. So we're going to have our x value is 16 equals our base is 2 to the y value of 4. Which is a true statement, right? 2 to the 4th power is equal to 16. All right, let's do another one. Let's say I have the log of 100 equals 2. All right, so I wanted to bring this one up. When there is no number written here for our base, it's automatically assumed that this number is 10. So anytime there's nothing written there, this is a 10. Okay, so 10 is our b, 100 is our x, and 2 is our y. Rewriting this. And you can do it with 16 equals first, or we can write it the other way and say that I have 10 to the y equals 100. Some people prefer to take the base, write that first. To the opposite side is the exponent equals the big number. How about this one? Let's say I have the log of 2 to 1/2 equals -1. So rewriting this one, again, my base, this is x, and this is y. So rewriting this would be 2 to the -1 equals 1/2. Right? Because a -1 exponent moves the 2 to the bottom. All right. Well, let's see why this is important. Example number 3. Now I'm going to ask you to evaluate the log. Okay, so you're going to have a log written, and it's not equal to anything. So let's say log base 3 of 27. All right? It doesn't have anything equal to it because you're evaluating it. So the first thing I want you to do is set it equal to a variable. I don't care what variable. I'm going to start with y. I'm going to be switching it up. So here are what I want you to think about. 1, I want you to change this to exponential. That's going to be our first step. Okay? So to rewrite this, this is 3 to the y equals 27. Step 2, we need to get the same base on both of them. So we're going to get like bases. All right, when I say base, this is 3 to the y. How else can I write 27 with a base of 3? 27 is 3 to the 3rd power. So then, once you have the same base, then you can compare the exponents. In this case, because the bases are the same, we're now to a 1-to-1 function, which means our exponents are equal. So I can just set my exponents equal to each other, or in this case, y equals 3. All right, we're going to do another one. So evaluating these logs and being able to switch it like this is super important to when we are solving equations. So I really need you to do it this way, okay? I'm being very, very adamant about it, simply because you can take your calculator and type in log base 3 of 27 and get an answer. But that's not going to help you when we start solving equations. You've got to be able to switch things around. All right, so today This is doing problems 20 through 31. This is the rest of the assignment. Is right here. It's just finding these exponents that they equal, or evaluating the log. So let's say I have log base 2 of 32. All right, so the first thing I want to do is set it equal to a variable. I'm going to use x this time. Then you want to rewrite it in exponential form, okay? So in exponential form, it's going to be the base, which is 2, to this side, which is x, equals 32. Now I can't write 2 as any other base, so that's got to stay 2 to the x. But 32, I can break 32 down, right? 32 can be 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2, right? So it's actually 2 to the 1, 2, 3, 4, 5th power. So x equals 5. Anybody have any questions yet? Okay. All right, let me keep going. I just have 3 more examples. All right. So here is example number 3. Again, I want you to evaluate, and I do not want you to plug it in your calculator, okay? No calculator. Dad, because we have to know how to do these when we start solving equations with this stuff in it, okay? So let's say I have log base 4 of 8. All right, so this time I'm going to set it equal to W. Sounds good? All right, now I have to rewrite it, okay? So I have 4, which is my base, to my variable, equals 8. Now, I've got to get the same base. And remember when I say a base, it's to an exponent. I cannot make 8 into 4 to anything, right? 4 to the first is 4, 4 to the second is 16. So it doesn't fit with 8. So I'm going to have to find another way. 4 is the same as 2 to the second power. And I'm going to put raised to my W. Okay? When you have an exponent raised to an exponent, you multiply those. So this is actually 2 to the 2W. On this side, 8 can be written as 2 to the third power, or 2 to the third here. Now, we have a one-to-one function because the bases are the same. I can set my exponents equal to each other. So I have 2W equals 3. Solving for W, right? W equals 3/2. Okay, let me try another one. How about example number 4? Say I have log base 36 of 6. Okay, so first thing I'm going to do is set it equal to x. Now I'm going to rewrite it as 36, that's my base, to the x equals 6. Now what can I get in common in these two? 6 is just 2 times 3. But 36 can be 6 times 6, right? So this is 6 times 6, or 6 squared, raised to the x. I can multiply my exponents. Equals 6 to the first power. My bases are the same, so I can set my exponents equal to each other. 2x equals 1. Solving for x, divide both sides by 2, and x equals 1/2. Well, that makes sense. If I plug it back in here, 36 to the 1/2 power, that means the square root of 36. That equals 6, right? All right, again, still no questions? Anybody at all? Okay, and example number 5. If I have log base 7 of negative 49, and I want to evaluate it, I'm going to set it equal to y. Then I'm going to rewrite this as 7 to the y equals negative 49. Is there any exponent I can make that's going to make 7 a negative number? There is no way multiplying 7 times itself however many times that I'm going to get a negative number. So this is no solution. You can never, ever, ever have a negative number behind log. Never have a log with a negative number behind it, okay? This is automatically no solution. All right, so what do you guys think? Good. I hope so. This is one of my favorite chapters to teach, so I can't wait till we get back and we start working with it. Because it's kind of using the logic that comes with math, manipulating, and algebra kind of all fit together. Yeah, so I think you guys will enjoy this chapter once we get going. And we end up using it a lot along the way. So that's all I have for today. Your homework, I posted in Google Classroom. I took a picture of the page. It is page 456. And we're doing 12 through 31 all, simply because the first 8 of them, you just got to rewrite them. There's no math or anything to do whatsoever. So it should go pretty quickly. If you have any questions, let me know. Don't forget to submit the homework from today. And tomorrow we're going to have a review with Simon, and that'll be it until after break. All right, you guys, if you have any questions, let me know. If not, I hope you have a great afternoon. I think you guys are starting softball practice today, aren't you?